Hey guys, so today is Monday the 16th for A Day, and then Tuesday the 17th for B Day. I will be out all of this week because I will be having a baby. We're gonna have the baby actually tonight. Today, the the date of this video is Wednesday the 11th. So I'm just making the video early right before I'm gonna go out. So I'm gonna be out the rest of this week, Thursday and Friday, November 12th and 13th. And then I will be out all next week, just kind of chilling with the new baby. That's going to be nice. I will miss you guys though. So this is the only video I have for this week. This one's going to be kind of long because it's got a lot of stuff that I want to cover. And at the end of this video, I'm going to provide some examples. If you need to watch the examples and kind of get more practice, go ahead. But if you don't need to, then you don't need to, okay? I'm going to make this an ed puzzle, so I need you guys to answer the questions here. So Monday and Tuesday this is the week before Thanksgiving. This is our last week before Thanksgiving. We're going to have today for a lesson, and then on Wednesday we're going to be testing. So let me show you guys the calendar here. As soon as I can find it, here's our calendar. So I put the this week's stuff here. So this is this week. So Thursday and Friday, you guys will be watching the second video from Electron Configuration and then completing the notes. And I did put an answer key in the notes. So if you open that, that's the link right there to get the notes, and it'll have you make a copy. Make sure you click make a copy, answer the questions, and then click share, click change link to Garland ISD, and then you can just send it to me or paste that link into Canvas and submit it through Canvas. Either way is fine. Okay, because if you send it to me, I'll get an email, and I kind of save those emails. I put it in a folder that says, notes to grade, and then when I grade them, I go through that email folder. Or I go through Canvas. I go through Canvas and look at all the assignments. So there's our answer key. I'm hoping you guys could read this. I tried to make it so that you could read this. And then at the bottom, I've got a whole bunch of electron configurations. You guys do not need to write that, okay? I just put that there for reference, okay? So if you need the electron configuration this is elements 1 through 33. I did 33 of them. That took a little while. So I did 1 through 33 so that you guys have it, and you can see how to write the electron configuration for 1 through 33. The first page here, hydrogen all the way down, and then all on the right side down to argon. These are all what we call the full electron ground state electron configuration. So this is the full ground state. And then what I did at the next page is I wrote the full ground state configuration for potassium, element K, and calcium, but then I also wrote this shortcut. And so I'll show you guys how to do the shortcut today. So these are on the next page. Since they're really long, I just wrote the shortcut for these guys. And I'll show you how to do that. But you guys do not need to write these, okay? So there's our answer key. Today is day 12. So we're going to be doing electron configuration practice, which is this video, and the ed puzzle. So you need to answer the questions in the ed puzzle and make sure that you're understanding the concepts. It is a little tricky. And then we're going to have some classwork that I need you guys to do. I'm going to make a video where I go through the classwork as well. So be looking for that video. On Wednesday and Thursday this week, again, this is our week before Thanksgiving. Let's see, that's the typo there. Wednesday the 18th, Wednesday the 18th and Thursday the 19th, we're going to be testing on Unit 3. So this is going to include atomic and electronic structure, isotopes, average atomic mass, electron configuration, all this stuff. And then on Friday, it'll be a B day, and it's the B day right before Thanksgiving break, so I'm going to have a makeup day. All right, and I hope you guys have a great Thanksgiving holiday. Make sure that you're safe. Okay, that's actually very important. A lot of people are letting their guard down, and cases are getting out of control again. So I know we all want to live our lives and do everything as normal, but you still need to protect yourself. It's just not worth the risk to me. To bring it home and to give it to your family. And more families are seeing that. More and more families are seeing that, one family goes and visits another, and then they have it, and then they spread it. And yes, it'll go away, but it's not like the regular flu. So it's not just a week thing where you're down. It's people are recovering for 6 weeks, and there's major issues. They're seeing a high percentage of people that have had it having some kind of mental issues, and a lot of other issues that they're seeing. So it's just not worth the risk. Okay. Let's see. Let's go back to our notes. All right, so today is day 12, Monday the 16th or Tuesday the 17th, whether you're A day or B day. I need you guys to do the electron configuration ed puzzle, which is due today by the end of the day, so midnight. And then the classwork is going to be due Wednesday by midnight. And then again, we'll be having a Unit 3 test on Wednesday. All right, so the goal here is for you guys to really get a grip on electron configuration and writing electron configurations and understanding all the details. Okay. All right, electron configuration ed puzzle is going to be due today by midnight, and I just need you guys to answer all the questions in the ed puzzle. Remember that it saves automatically after each question. All right, so this will be due the 16th for A day and the 17th for B day classes. And then make sure you guys complete the classwork. Again, look out for a video that I will give you guys probably on Canvas with this assignment. So if you find this assignment on Canvas, I'll have a video there that'll help you. All right. Okay. So now let's go where we were after we left off with the video. Let's see. Did all this stuff. Remember that as you go across the periodic table, you add electrons to that valence shell, which is the outermost shell. And so we should be able to write Lewis dot diagrams for these guys. And let me review that real quick. So each shell, as you go across, or each element as you move across the periodic table, you add one valence electron. So if it's in group 1, for example, hydrogen, it's going to have one valence electron. So the way that we write Lewis dot diagrams is we put the symbol for the element from the periodic table, and then we put a dot there. And let me double check and make sure that I'm presenting the right screen. Okay, this looks good. Okay. And then group 2, let's say magnesium, will have 2 dots. And where you put those dots don't matter, but I try to show them separated out because they repel each other. They don't like each other, so they're going to stay far apart. Third one would be aluminum. That's group 3. Remember on the periodic table it says group 13, but keep in mind that it's just group 3. Okay, so it's got 3 valence electrons. And then carbon is group 4. Nitrogen is group 5, so 5 dots. Oxygen is group 6 with 6 dots. Fluorine is group 7 with 7 dots. And then let's do argon up here. Argon will have 8 dots. So we have 4 pairs. And then it's full, okay? So that's the full outer shell. So as you go from hydrogen over, let's look at our periodic table. We're going to fill that outer shell. So as we go from this group over, hydrogen to helium, or hydrogen to beryllium to group 3. Each time you move across one at a time, you're adding valence electrons to that outer shell. All right, group 1 has 1 valence electron, group 2 has 2. So it's 1, 2, skip a few, then you go to 3. It's got 3 valence electrons. Each group, the group number tells you the number of valence electrons. Okay, and there's groups 1 through 8, not counting the middle and not counting the bottom of the periodic table. If you want to guess at the rest of the elements, most of them have 2 valence electrons. Okay, but if it's in group 1 through 8, then it'll have that many number of electrons. Okay, so we're good on that. Okay, how is the periodic table arranged? Each of the rows are periods. So each row in the periodic table is called a period, and each of them indicates an electron shell number, or what we call a principal energy level. There's 1 through 7. So when we write the electron configuration, the very first thing for each electron configuration and each piece of the configuration, which is kind of like an address. All right, electron configuration is which shells are involved, what are their names, and how many electrons are in each shell. So it's a way of representing the electronic structure. The very first thing that you'll see with each piece of the electron configuration is the principal energy level. It'll say 1s or 2s or 3s or 4d or 3p. So that number in front tells us the principal energy level, and we can find that on the periodic table. It is the row number, all right? So if it's in this group, this is group 1. Not group, this is period 1 or row 1. And so that is the first principal energy level. And that's actually called the 1s. Okay, and then we have the second group, which is these two all the way over to these 6. Okay, so these two right here make up the 2s, and then these 6 make up the 2p. Okay, remember we have 4 shapes, S, P, D, and F. There's the S's are over here, the P's are over here, the D's are in the middle, and then the F's are down here at the bottom of the periodic table. Okay. Okay, so as you go down the periodic table, you add levels, you add shells. So let's look at a picture of that. So if you had hydrogen, hydrogen looks like this. It's got 1 shell, it's got the 1s, and there's 1 electron in there. Okay, there's only 1 electron on hydrogen because it's element number 1. Now let's go to lithium, group 2, or period 2. He's got the same 1s shell, and it's actually full. He's going to have 2 electrons in it. It's going to be full. But lithium has 3 electrons because he's atomic number 3. And so we have to add another shell. So as you go down, each time you go down an element, you add a shell, and the atom becomes bigger. And there's 1 electron in that outer shell, and that outer shell is called the 2s. And we can put the exponent 1 indicating that there's 1 electron in that shell. So when we write 1s, that means the 1s level, principal energy level 1, and it's got 2 electrons that currently occupy that space. 2s is the second level, but it's on the s block, so it's a spherical orbital, and then it's got 1 electron in it. And then if you add the exponents here, 2 plus 1 is 3. And that's what we should get. We should get 3 because the atomic number of lithium is 3, right? Everybody see the little 3 there? Okay. Let's go to sodium. Sodium is in group 3, and so, or I keep saying group, but period 3. It's on the 3rd row of the periodic table, this blue row. And so there's our nucleus. There's the 2. There's the 1s orbital, and it's got 2 electrons in it. So we can take 2 electrons and put it in that orbital first, and then we build our way out. And then we have the 2s, and it can hold 2. Okay, but then we have the let's see, 1s2, 2s2. Then we have the 2p6. Okay, and then it's got 1 more shell, and that's called the 3s1. So it's got 1, 2, 3, 4 shells. But it's only got 3 energy levels. Okay, it's got the 1 for 1s. It's got the 2, which is the s and the p. Those are both part of the second energy level. Okay, but then it also has the 3s. Okay, so since it's on the 3rd row, it'll have 3 shells. And actually, we could write it this way. Maybe this is confusing. So here's our nucleus. We can say, okay, there's the first energy level, and it can hold 2 electrons. So let's put 2 electrons in there. And then we have our second level, which will hold 8. 2 of them will be in an s orbital, and the other 6 will be in the p orbital. So that'll be the 2p. And then we have the 3rd shell, which will have 1 valence electron. So we have, so that'll be level 3. So the sodium atom is on the 3rd row on the periodic table, and it will have 3 levels. So each time you go down the periodic table, you can add another level. And then potassium, it'll have 4 levels. It'll have the 4s. And then rubidium will have the 5s, and so on. Okay? Okay. Let's see. So remember, there are things called orbitals. An orbital is a region in space where an electron likes to hang out. There are 4 shapes of orbitals. S, P, D, and F. S is the simplest, and it stands for sphere. P is a little bit more complex. It's a peanut. And then D is a little bit more complex, and then F is a little bit more complex. And you got to be able to look at the periodic table and tell where they're at. So we'll talk about that. So these are regions of space where an electron likes to hang out. These are called sublevels. Let's talk about, well, we'll get to this in a little bit. I don't want to repeat myself too much. Let's see. So here are the shapes of them. Here's the S. It's just a sphere or a ball. Okay. So that's the S. It can hold 2 electrons in there. Okay. It can be the 1s. It can be the 2s. It can be the 3s. So basically, as you add shells to the atom, they can be the 1s, the 2s, the 3s, the 4s, the 5s, all the way to 7. So you have 7 levels. And if you look on your periodic table, right here, notice that there are how many rows on the periodic table? 1, 2, 3, 4, 5, 6, 7. And then these are also 6, 7. Okay, so that's our energy levels. Okay, 7 energy levels. Okay, so we've got our S, and then we've got our P. They look like this. There's 3 of them, and each of these lobes can hold 1 electron. Each of these is an orbital, so it has 3 orbitals. That's one, that's another, that's another. So 3 orbitals, and a total of 6 electrons can fit in a p orbital. All right, and then 10 can hold in the D, and 14 in the F. So we can hold 2 in the S, 6 in the P, 10 in the D, and 14 in the F. Okay, and all we're going to be doing is counting electrons. Look and see how many electrons you have in your element, and then write the configuration and make sure that it shows that many electrons, and then I'll show you how to build up the shells. All right, stay with me. Here is the periodic table arranged by sublevel or by shape. So this yellow region are S block elements. It also includes helium. Okay, so let's label it. This is the 1s. The next level is the 2s. This is the 3s. Potassium is the 4s, 5s, 6s, 7s. So if the element is in that position, let's say potassium here. Potassium is on the 4th row, so we can say, okay, 4s. And we say S because it's in that S block. It's in that area. And so we know that the valence electrons, or the outermost shell of that atom, will be the 4s. And it's got 1 electron in there because it's the first element right there. On that level, it's the first element on that 4th row. And so we call it 4s1. Okay. Now the P block elements are over here in the blue. And so this is called the 2p is the first one. The boron through neon. The next one is called the 3p, and it's got those. Aluminum through argon, 13 through 18. And then you've got the 4p, 5p, and 6p. And actually there even is a 7p. It's just not shown on this periodic table because these are all elements right here. This goes all the way to 118. I think 118 and 120. All right. And then the D block elements are right in the middle. The first level here, I know it says 4 on this table, so it looks like this is going to be the 4D, but this first level is called the 3D. Okay, and so you start getting 3D electrons when you're on the 4th row, but it's the 3D, not the 4D. Okay, so just remember that the first set of d orbitals is called 3D, and so this is the 3D. Elements 21 through 30, scandium through zinc, these guys right here. That's 3D. And then the next one, and let me clean this up. So that's the 3D there. The next one is the 4D. Next one is the 5D. The next one is the 6D. Okay? And that's all the Ds that we have. All right, and then the F, there's the 4F, which is this one. even though it might look like it's the 6F based on the numbers here, but it's called the 4F and the 5F. Okay? So let's work down a periodic table and see what shells, let's see what the order is. So let's start with hydrogen. Hydrogen is in the 1s, and so is helium. So that's the 1s. Then we go to follow atomic number. So you go across, down, and back over like a typewriter. Isn't that how a typewriter works? Across, down, and back to the left. And so now we're back at lithium. So that's going to be the 2s because it's the second row in that s block. So that's going to be 2s. So first we have to fill the 1s, and then the 2s. And then we're going to skip across here, go to boron, and remember that's the 2p. It's 2 because we're still on that second row. Okay, let me clean that up a little bit. You're still on that second row, right? And so that's the 2p. And you got 6 electrons you can add there for each of those elements. 2p1 will be boron, 2p2 will be carbon, 2p3 will be nitrogen, all the way to 2p6. And then once you get to 6, you're full. All right, now let's see what our next element is. We stopped at neon. We got all these guys done. All right, our next element is this one, which is 3, and it's the s. So the next orbital is the 3s, and it can hold 2. So that'll be sodium and magnesium. So that's the 3s, and then we're back over here. This is the 3p. So the next one is the 3p. That'll get rid of those. That's 3p1 through 6. And then you go down and back to potassium. That's the level 4. So that'll be 4s will be the next one. And then the next element is scandium here. All right, element 21. And that's going to be the 3d. So let's write our order. 1s, and then 2s, and then 2p, and then 3s, and then 3p, and then 4s. And then now we're at 3d. After the 4s is the 3d. And I know it's backwards, but that's fine. So you got to fill this 3d first. It can hold 10 electrons. 3d1 is scandium, 3d2 is titanium, all the way to 3d10, and then it's full. What's next? 4p. Remember, this is 2p, 3p. So this next one is the 4p. And I don't have room to write this, but that's 4p. Okay, what's next? After the 4p, we're going to come over here to rubidium. So that's 5s. And then the 4d. And then the 5p. And so on. You keep going. So let's rewrite this, and let's do the whole periodic table. I know that sounds fun, right? So we're going to do 1s is this guy and this guy. So those are done. Let me cross them out. It's 1 because it's the first row, and it's s because those are s block elements. See the yellow? So that's 1s. The next one is 2s, and that's going to be those guys. So we're going to cross those out, 2s. And I'm going to put the little exponents up there too. So let me write this a little neater. So we're going to write 1s2, 2s2. That leaves us at beryllium here. Now we're going to skip across to the 2p. And it can hold 6. So I'm going to put 6 in it. And that will get us to neon. And then we're going to go here to sodium, which is going to be in A, which is 3s. And we can put 2 in there, and that'll count for those 2 guys. And then we'll skip across to aluminum, which is the 3p. And we can put up to 6 in there to get to argon. And then the 4s will be potassium. We can put 2 in there. That'll kill potassium and calcium. And then we got to do the 3d10. And then let's see, this will be 4p6. And then down here will be 5s2. And then 3d10. That's 4d10. So then that's gone. And then this will be 5p6. Those are gone. 6s2. What's next? 5d10. You just continue. So 5d10 would be next. And then the 6p will be, let me erase. So this will be the 6p. This will be the 7s. That's the last s shell. And then we have the 3, 4, 5, 6. That'll be 6d. And then we would have, let's see, 2, 3, 4, 5, 6. This will be 7p here, these guys right here. Like I said, there's no elements on this periodic table, but there's actually elements there. And that'd be the 7p. And then we also have the S down here. And I'm going to try not to use the Fs because they get really complicated in the order of things. So just keep in mind that the F block elements are down there. So that means that elements that are down here, they have their valence electrons in what's called an F orbital. Okay. All right, let's continue. Ooh. All right, so here's another table showing how they're organized. This is the 1s. Right here, 1s. So 1s, 2s, 3s, 4s, 5s, 6s, 7. So there's our 7 s's. And just keep in mind that that tells us that the valence shell is a s orbital. So it's a sphere. So when I draw an atom and it's got a sphere, that's kind of what I mean. So that's the 1s, 2s, whatever. It's a sphere either way. And then if you're over here, you've got 2p through 7p. 3D through 6D, and then 4F and 5F. Okay? All right. So there's our 7 principal energy levels. This is the number of shells. There's our group numbers, number of valence electrons. As you move across, you add valence electrons to each shell. There's the S, there's the P, there's the D, there's the F. All right, remember that helium is also part of the S. Okay, so S is those guys and helium. So that's 1s1, 1s2. Okay, so let's look at the electron configuration a little bit more. So when we write the electron configuration, what does the number in front mean? It tells us the principal energy level, 1 through 7, depending on what row it is, okay? And then the next one is the sublevel in red here. That's the shape, so it's either an S, a P, a D, or an F. That's your 4 options. And then the exponent is the number of electrons that are in that space. They're in that cloud zipping along. So remember that S can hold 2. It can be 1 or 2. You can put 1 electron, so you can write 1s1. You can write 2s1. You can write 2s2. You can write 2s2. You can write 7s2. But it can only hold 2 electrons. That's it. Okay? After that, it's full. And that's because the electrons repel each other, and it can only hold 2. And then when you got a p orbital, it can hold up to 6. So you can have 2p1, 2p2, all the way to 2p6. Then it's full. So those are your options. And then when you get to the D, the D's can hold 10. So you can have 3d1 all the way to 3d10. And then when you have the F orbital, you can have 4f1 all the way to 4f14. It'll hold 14 electrons. Okay? The number of electrons will equal the atomic number, at least until we talk about ions a little bit more, which will be later. Thinking after Christmas. Okay. Okay, so let's do some practice. So lithium is atomic number 3. It's in group 2, period row 2. So it's going to have 2 shells. The group number is 1 because it's the first element on the periodic table, or the first row on the periodic table. How many valence electrons? It's got 1, and it's got the S sublevel, and that's the electron configuration. 1s2, 2s1. So let's go back to our periodic table and talk about how we got lithium. How did we get this? How did we get this 1s2, 2s1? Okay. Let's go back to our periodic table. All right, Mr. Periodic Table. I'm going to use a different one than that one. I'm going to use this one. Okay. So when you start electron configuration, you got to remember that you have to start with hydrogen. You have to start with element 1. And so let's take our, that's our nucleus. We're going to add electrons to that shell. That shell will be called the 1s. You always start with 1s. If we're going to do the configuration for hydrogen, we would write 1s1, and that would be it. 1s1 is the electron configuration for hydrogen. If we wanted helium, we would write 1s2, and that would be it. And so you would put 2 electrons in that shell, up to 2, and then it's full, okay? But since we have lithium, which is neither helium nor hydrogen, we have to count those 2, but then keep moving. So I'm going to write 1s2 for my configuration. And if you look at this picture here, I wrote the 1s, and I put 2 electrons in it, okay? So just keep, So just keep in mind that the first shell, every time I say, okay, the first shell around the atom, just know that it's the 1s, and it can hold up to 2 electrons. So we're going to put 1s2 for that, for those 2. Now we go to lithium. Lithium is right here, and it's in the 3s. It's 3 because it's on the 3rd row, and it's s because it's in that s block, these yellow elements. And so we're going to write 2s, and then we can put up to 2 in there, but we only need 1 because right now we've already put 2 electrons in the first shell. We have a total of 3 electrons because we're lithium, right? Lithium has 3 electrons. And so we just need to put 1 electron in there. Now what happens when we add up these electrons? What is 2 plus 1? We get 3. What is the atomic number of lithium? It's 3. And so now you can check that electron configuration. So 1s2, 2s1. So that's how we got it. You're looking at the periodic table and doing this. Okay. Okay. Click, 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 click. Okay, let's do boron. So boron has 5 for its atomic number. It's on row 2. It has 2 shells. It's in group number 3. It has 3 valence electrons. The sublevel that it has is the p, and so the electron configuration is 1s2, 2s2, 2p1. And let's see how we get that. All right, so let's go back. To our periodic table that I like. I like this one. Okay. All right, again, you have to start with the 1s. So we're going to start with hydrogen and helium, and we're going to write 1s2. So if you think about our atom, we've got our first shell. That first shell is called the 1s, and it has 2 electrons in it. So let's put 2 electrons in this guy. There we go. They're happy little electrons zipping around. Okay. Now, next one will be lithium right here. So we did hydrogen element number 1. We did helium element number 2. So the next element is lithium, which is element number 3. So just follow the atomic number here. We go to lithium next. Lithium is in the 2s. And so I'm going to make my next shell. I'm going to call it the 2s. And I know it can hold 2. So then if I'm writing my configuration here at the top, I'm going to write 2s2. Okay. So that's my configuration so far. We're not there. How do we know we're not there? Well, we just did lithium, which is 2s1, and 2s2 would be beryllium. So this would be the electron configuration for beryllium, Be, not boron. All right, so we got the 2s. Now, if we look at beryllium, it's the last element in the s block, and so that's element number 4. And so now what we have to do is skip across to element number 5, which is boron, and it's in the 2p. Why is it 2p? It's 2 because it's on that second level of the periodic table. Right there. Everybody see that? The second row on the periodic table. And I'm trying to draw it. And then it's p because it's in the p block. Okay. So our final configuration, our final answer for $1,000,000 will be 1s2, 2s2, 2p. So we decided it was the 2p, but which element number is it in that p block? This is 2p, 1, 2, 3, 4, 5, and 6. So it's the first element, so we just put 1. Now add up your exponents. 2 plus 2 plus 1, what does that give us? 5. Is that equal to the atomic number of beryllium or boron? It sure is. That's 5. Okay, so add up your valence electrons, or add up your electrons in each shell. and it'll equal 5. Beautiful. And I hope this is making sense. I know this is abstract. Okay, so we did lithium, we did boron. Here's the complete configuration, and we did this a minute ago. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, da 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 da. It keeps going. Okay. All right, let's write the full configuration for these guys. I'm going to do this in red. So hydrogen, 1s1. Helium, 1s2. Lithium, 1s2, 2s1. Beryllium, 1s2, 2s2. Boron, 1s2, 2s2, 2p1. Carbon will be 1s2, 2s2, 2p2. All right, so there's the electron configuration for those guys. Beautiful. I'm not going to do these again. Sodium. Let's do sodium. Sodium is element that has a number of electrons is 11. Okay, so remember the first shell is the 1s, and it can hold 2. So that's 2. So let's do 11. 11 minus 2 is 9. So we have 9 electrons left. And then it's the 2s2. We're going to subtract that. We have 7 electrons left. Next one is the 2p, and it can hold 6. So let's subtract 6, and now we have 1 electron left. Our next shell is the 3s1. Okay, and so that's our configuration. 1s2, 2s2, 2p6, 3s1. Let's look on the periodic table and make sure that makes sense. Let's go back. Like I said, I like this one a bit better. So let's look at sodium. So here's hydrogen and helium, 1s2. Let's cross those out. Those electrons are filled. Next one is 2s2. That's those guys. Next one is 2p6. That's those guys. And then look, sodium is the first element on the third block of the third row of the S block. So that's 3s1. So sodium would be 3s1. Magnesium would be 3s2. Okay. So again, this is the full ground state electron configuration. Ground state means that it's in the lowest possible energy level, or lowest possible energy state. It's not excited. Okay. And I know you guys aren't excited for this chemistry stuff. This is difficult. It's kind of a cool pattern though. So we did sodium. All right, let's go over a couple more things. What are the rules for filling electron shells? The lowest energy shell must be filled first, which is why every single atom on the periodic table, the electron configuration starts with 1s, because that one must be filled first before you can put electrons anywhere else. Okay? The first shape, the 1s, can only hold 2 electrons, and only 2 electrons can occupy a single orbital. All right, so if we look at each of our sublevels, this is the number of electrons that it can hold. 2 in the S, 6 in the P, 10 in the D, and 14 in the F. Okay. So there's these, kind of the same thing. Now, how many electrons can fit, how many orbitals can fit in each? This is orbitals here. Apologize. Orbitals. So how many orbitals can fit in each? What you can do is take the number of electrons and divide it by 2 to get number of orbitals. Okay, an orbital is a space where 2 electrons can hang out. So there's 1 orbital in the S, there's 3 in the P, there's 5 in the D, and there's 7 in the F. Okay. When writing electron configurations for any element other than hydrogen or helium, you must what? You must start with the 1s, and work your way up to the atomic number or number of electrons. All right, and then so here's the descriptions of these, and so y'all can just copy these from the video or from the PowerPoints. So the hydrogen, it has 1 electron, and so it's 1s1. And the reasoning for that is the first electron on hydrogen goes in the lowest possible energy level, the 1s. All right, let's look at helium. 2 electrons, 1s2. The 2 electrons for helium will go in the lowest possible energy level, the 1s. Since the 1s can hold 2 electrons, it's now full. And so we could fill that first s orbital. And so 1s2 is a configuration for helium. Now let's look at lithium. 3 electrons, 1s2, 2s1. Lithium will require the 1s shell and the 2s shell because it's on the second row in the periodic table. The first 2 electrons will go in the 1s, and it's full. Then the third and last final electron will go in the 2s. And so that's why we put a 1 there. All right, so there's our complete filling again. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, da, 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 da. Okay. And that's it written out. Here is the complete periodic table. This is showing the valence electron shell for each of these atoms. So like right here, this is hydrogen. So hydrogen is 1s1. So that's actually the configuration for hydrogen because it only has one shell. Same thing with helium. This is a configuration for helium. And then the ones after this is just the outer ones. So it doesn't include the initial ones. So if you were to write the electron configuration for, let's say, 4s2, you're going to have to include everything before that. So you're going to have to include the 1s2, which will be those two. So 1s2. And then you're going to do 2s2. We'll get rid of those guys. And then 2p6, which will be those guys. And then 3s2, those guys. 3p6 will be those guys. And then finally 4s2. So 4s2 is just the outer one. You have to write everything before it. Okay. All right. And I think that's it. I don't want to talk about ions. I don't want to talk about excited states. And so I think we're good. All right, guys. Like I said, be looking for a video over the classwork, and that will help with the classwork. I'm about to make the video just in a minute. All right, guys. Thank you.